All right, let's begin our final lesson for this unit, which is putting everything together and solving problems involving sinusoidal functions. So in particular, we're going to put our skills we learned from our last lesson into this lesson. And again, that's just creating equations from a given problem. All right, so the problem could involve just a word problem with only words. Perhaps it'll be a graph. It'll be one of the two where we have to create an equation in order to begin to answer other questions specifically to the word problem given. All right, so let's start with a quick recap. And I've already written everything out here to save a little bit of time. We've got the definitions for period, axis of the curve, and amplitude. These three things are going to be instrumental in this lesson, hence why we're going back over it and just how to calculate it. So the horizontal distance to complete one full cycle is known as the period. And if I were to write out the formula to calculate period, it would be 360 divided by k. Now, in the word problems that we're going to have below, you'll be able to decipher what the period is potentially, okay, which means you can find k as well. And so if I rearrange this formula to isolate for k, it's actually 360 divided by the period, okay? So if you were to rearrange this formula, you would actually get k equals 360 divided by the period. And that's going to be powerful for us because if we're going to write out the equation, we need to be able to solve for k. And if we have the period, we can do that. Axis of the curve, or equation of axis, is the center line going through your sinusoidal function. It's represented by the letter c in the function in your sine or cosine function, okay? Also, you can also find it by taking your maximum y value, adding it to your minimum y value. That says y minimum, by the way. Okay, that's kind of hard to read if I maybe fix that up a little bit. Okay, your y minimum. And then divide it by 2, so essentially finding the average. You can also find it that way. Now there's also the amplitude, which is the vertical distance from your equation of axis to your max or your min. It's always stated as a positive measurement, and it's represented by a in your sinusoidal equation. There's also a formula to find amplitude. It's essentially careful. In this formula for amplitude, you subtract y max minus y min, whereas in the equation of axis, you add. I always remember this through thinking on how to find the average of, let's say, two tests. Remember that your equation of axis is your average line, your center line. So if you were to find the average of two tests, you would add the two test marks together and then divide by 2. Okay, so that's how I kind of separate myself from these two formulas and remember that it's the equation of axis that is plus and it's amplitude that's minus. On a graph, it'll look something like this. So you can see your amplitude is your vertical distances from your equation of axis to your max and min. Your period is the horizontal distance for one full cycle, and your equation of axis is that center line going through your function. If we were to summarize how to find the equation that models a given function, okay, we would start by determining the amplitude. Based on the question that's given to us or the graph or the information given, try to figure out your amplitude, your equation of axis, which is your c value, and then figure out your period, which will help you find k. All right, because as I mentioned earlier, k is equal to 360 divided by the period. All right. You're going to determine then which function you want to use, a cosine or sine function. Okay, and I'm going to recap here that a positive sine function has this shape here, and a positive cosine function starts at the max and does this. So you have to choose which one you'd like to use. Now, remember also that you can get a negative sine function or a negative cos function, and potentially not have any phase shift. But we'll get to that. You'll see that there's a problem we'll work on that deals with that, and we'll look at that when the time comes. Then, depending on whether you chose cosine or sine function, determine your phase shift, left or right, based on the function you chose. That phase shift is your d value in your equation. And then lastly, write out all your calculated values into y equals your sine function or also your cos function. Okay? And here is where I'm going to just quickly discuss what a positive sine curve looks like. Now you can also use a negative sine curve potentially, right? If that suits your model and that fits without any phase shift left or right, then using a negative sine curve, which is simply reflected across the x-axis, so instead of going up, it's going down, right? Then there's the positive cosine curve, which we know what it looks like, and then the negative cosine curve, where instead of starting at the maximum like the positive cosine curve does, you start at the minimum. All right, let's dive in and let's figure out some equations here. So we've got some examples. We've got 3 examples where we're given graphs and we need to determine their equation. Okay, so let's start there. So if I'm looking at this, okay, first thing I want to do with this graph is I want to find my A, my K, and my C. From there, I'm going to choose whether I want to use sine or cos, and then from there, I'll determine the phase shift if there's any. Okay, so let's find A, my amplitude, and actually I can probably just look at this graph and find it all, but I'm going to go through the act of calculating everything. It's your y max plus your y min divided by 2. Okay, so my maximum y value is 6. My minimum y value is 2. Oh, and I apologize there. That should be minus. There you go. See how simple it is to make that mistake? Okay, be careful there. 6 minus 2 is 4, divided by 2 is 2. So our amplitude is 2. Okay, so let's box that answer. Let's find our C value now. This formula is y max plus the y min divided by 2. So now we have 6 plus 2 divided by 2, and our C value then is 4. And that makes sense. If I go to my graph, clearly my center line is going through y equals 4. Okay, my amplitude is clearly 2, going from 4 to 6. Okay, so you can take this information from your graph, or you can substitute it into a formula. Lastly, let's find our period. Okay, so I'm just gonna clean up what's here right now so I can see a little bit better. Let's find our period, and then from there we're gonna find K. So your period is the horizontal distance for one full cycle, right? So let's see, if I'm starting here on my equation of axis, one full cycle is right there. Okay, do you see that? Now, we kind of need to guess where we're at that point. Okay, so if we can see this a little bit better and go down to here, okay, this line, by the way, is 90, and it looks like we're just under halfway between 60 and 90. So I'm going to say that we're at about 70 degrees there. Okay, one full cycle at about 70 degrees. The other thing here that you can do, actually, let's just keep it at that. So let's assume that it's at 70 degrees. Now, you can calculate it in different ways. And I'm going to show you. Is you can also, for example, take your distance. This will always work. Take your distance from maximum to maximum. Okay? So max to max. And if you take that horizontal distance, it should also give you about a 70-degree angle. So here we're at 90. So we do 90. Here we're at approximately I'd say 160, okay, if I had to guess. If you had to find the distance that goes from 90 to 160, how would you find that? You would subtract 160 minus 90, and you still get 70. Okay, so you can find, you can do it starting here from your EOA, like we did, and realize that at 70, or you can pick any two maximum or minimum points on your graph and find the horizontal distance between those, and it should also be the same value. Let's find K now. K is equal to 360 divided by the period. So K is equal to 360 divided by 70. Okay, so throw that into your calculator and you should get approximately 5.14. Okay, 5.14 should roughly be your K. So, it's not the easiest number to work with. You can keep this as a fraction as well. Okay, so if you divide everything by 10, you would get 36 over 7. So keeping that as a fraction will be obviously more exact than doing it as a decimal. Okay, I won't be picky in this situation here which method you choose. Okay, so we found A, C, and K. Now we need to figure out which function we want to use. So let's clean up my graph here so we can see better. Okay. Well, I know that the sine function actually starts at the equation of axis, just like this graph does. And that's without any phase shift, right? So that's not moving it left or right. So that's ideal. Like if I can find an equation where there's no phase shift, right? This is following a sine curve because it's starting at the EOA on the y-axis. That's following exactly what I'm looking for in a sine curve without any phase shift. So I can definitely use my sine curve, okay, without any phase shift. So if I were to write out the equation, it would be y equals a, which is 2, sine of 36 over 7. Now, I said no phase shift, right? Because it's already exactly where I want it to be. The EOA is on the y-axis, the starting point is right on the y-axis in EOA. So I'm just going to keep that as x, okay? No minus d or plus d, and then plus 4, okay? Now, I want to say that you don't have to use that equation. Let's say I wanted to use a cosine curve, okay? So let's say I want to use a cosine curve. And I know that the positive cosine curve starts on the max, okay? It starts on the max. So, actually, let's just undo there. If the positive cosine curve starts on the max, but this max is occurring, and you could take either max. Now, why did I choose that max? Here, let's talk about that first, right? Why did I choose this maximum versus this maximum? Because clearly this maximum would have less phase shift. However, right, what stands out about this point versus this point? Well, the fact that this, I know it's exactly on 90, whereas this, I'm kind of guessing where this might be for the phase shift, right? I'm kind of guessing there. So in my opinion, I like this point better. And so if the original function started at the maximum, the original cosine function, and it moved to the right 90 degrees, so it moved 90 degrees right, I could write another equation with some phase shift, right? So I can go to, this time use the cosine function of 36 over 7 times x. Now I'm going to have a phase shift. If I went 90 degrees to the right, then in my equation, I show minus 90. And so these two equations are equivalent. They're the exact same. So you can model whatever type of equation you want. You can do a sine function, a cosine function. I mean, the sine function makes more sense there because there's no phase shift if I use the sine function. Whereas if I use the cosine function, I can incorporate a phase shift right there. Okay, that the original function started here on the max and it shifted here 90 degrees to the right. Okay, and if you were curious, if you substituted an x value into either one of these equations, you would get the same answer. All right, let's look at another example. So the load on a trailer has shifted, causing the rear end of the trailer to swing left and right. The distance from one of the taillights on the trailer to the curb varies with the time as shown. Write an equation to model the distance between the taillight and the curb as it varies with time. Okay, no problem. So we're going to do the exact same thing as above. And look at this again. Okay. I can actually just really easily look at my graph because my graph's given to me. I can see my equation of axis is at 1.5. So this is my EOA. Okay, it's my middle line. I can just look at that and figure that out. So I'm going to do this a little bit differently. See how here I use the formulas to calculate everything? Well, because we're given the graph, this time around, I'm going to show you how you can just use what's given to you on the graph. So I know my EOA is equal to 1.5. Now this is also my C value. Okay, it's how much my graph got shifted up. If the original equation of axis was at 0, it clearly moved up 1.5 units. Okay, now let's keep going. I can figure out my amplitude just by looking at my graph as well. I go from 1.5 to 2, right? 1.5 to 2. So how much distance is vertical distance is there? 0.5. Okay, 0.5. So I know my A value for my equation as well. Now let's figure out the period which will help me find K. So the period, the horizontal distance for one full cycle is right there. It's from 0 to 2. Therefore, my period is 2. Okay. Now, remember what I said in the previous question. Now, I should probably write the units there. It's 2 seconds. Okay, now remember what I said in the previous question, that you can also do it from your max to max as well, because that is one full cycle right here, right? That's one cycle right there as well. So if we were to go to max, this is 0.5 all the way to 2.5, and that distance there would also be 2 seconds, right? 0.5 to 2.5. So you'll get the same answer regardless of where you take this repetitive pattern to figure out your period. You'll get the same answer. So now K is going to equal 360 divided by 2. So K is equal to 180. Okay. Now let's write out our equation and let's choose whether we want to use sine or cosine. Okay. Well, I know that sine is supposed to start at the EOA and the y-intercept, which this does. So it'd be easiest to use the sine function, okay, because it's starting at the EOA and the y-intercept, because it would have no phase shift. So if I were to write out my equation, it would look like okay, that's with no phase shift. 0.5 is your A, your K is 180, and your C is 1.5. But we know that you don't have to choose that equation, right? If you want, you can choose a cosine curve with this much phase shift, right? So the original would have started at the max. It shifted over 0.5 seconds, okay? And it shifted 0.5 seconds to the right, which means in my equation, it'll be minus 0.5. So if I were to write out a cosine function, I can do it as 0.5. So nothing changes with A and K and C. The only thing that changes is you get an x minus 0.5, okay, versus no phase shift in the sine function. Okay, those equations are equivalent. They're equivalent. You could sub in an x value for each of those and get the same answer for y. Okay? All right, last one. I like this question because I'm going to show you what happens, or the equation we can write when it's starting at the minimum on the y-axis. So it says a kite got caught in a windmill. Its height above ground is measured over time. Write an equation to model the height of the kite above ground as it varies with time. So once again, we've got a situation where we can figure out A, K, and C pretty easily. So I'll go back to using the formula. Again, I'm just swapping back and forth to kind of get you used to either way. So y max clearly looks like it's going as high as 17. And by the way, we should really understand what's happening here. A kite got caught in a windmill. So imagine a windmill going round and the kite is stuck on it. And if you're measuring the kite's height as it's going around the windmill, it's going to start, it got caught at the bottom. It's going to start to go up all the way to the top of the windmill. And then now, because it's a circular object, the windmill, it's going to go back down. Okay? And then go back. And it does this in a repetitive pattern. Okay? So tracking the height of that kite is following a sinusoidal function. So 17 minus a minimum of, looks like 3, divided by 2. 7. Okay, so our A is 7. Let's find our C. Okay, you end up getting 17 plus 3 divided by 2, which is 10. Okay, so C equals 10. Which makes sense because I can see that on my graph, the halfway line, the center line of my function is through 10. Okay, and now let's find my period. So the distance from a full cycle, so if I take from this point to this point, that's one full cycle right there. Okay, minimum to minimum will also give you a full cycle, and it's clearly 20 seconds. Okay, so that's the easiest thing you can do, is just in this case go from minimum to minimum. You could also do maximum to maximum. You'd still get 20 seconds, okay, and so on. Let's find K. Okay, 360 divided by 20, okay, should give you your 18, your 18. Okay. Now, let's determine what function to use. Okay, here's what I really want to go through with you before we end this video, part 1 of this lesson anyways. So remember that the cosine function looks like this, right? Starts at the maximum, does that. Well, if I were to have a reflection, and again, I can have no phase shift here. If I just reflected and I had a negative cosine function, instead of starting at the maximum, it would actually start at the minimum because it's reflected across the x-axis. So it would actually start at the minimum. Okay? So I can choose to do a negative cosine curve, okay, meaning I just make my A negative. If I do that, then I don't have to have any phase shift. Okay? So it's my easiest, my path of least resistance, where I don't have to really calculate any phase shift. So if I go like this, y equals, now remember the function is supposed to look like this. And I do y equals, now because my A is 7, I do negative 7 because I'm reflecting downwards. I'm reflecting across the x-axis. Cos, no phase shift here because I'm using my negative cosine curve. If I were using my positive cosine curve, I would need to have this much phase shift. So the original would have started at the maximum here, and it would have shifted how many units? to the right. 10. So 10 seconds right. So if I were to write an equivalent equation using a positive cosine curve, it would look like this. This is an equivalent equation. And it's minus 10 in my equation because I went right 10, which means you put minus the opposite sign in your equation there for D. So these two equations are identical to each other. Okay, if you subbed in an x value for each of those, you would get the same answer. One has no phase shift because we used a negative cosine curve. One has a positive phase shift, or does have a phase shift because we use a positive cosine curve. So I'm going to stop the video there, and I'm going to call this part 1 of our final lesson here, and we're going to do part 2 where we're going to really dive into just not even be given the graphs. We're just going to be given the word problem. We're going to be responsible for sketching a graph, okay, and then finding an equation of it.